Hello, everyone. This course covers PLC control of three-phase motors, contact and coil instructions, and their applications. The target results for this session are the following four. 1. Understand the types of bit logic instructions. 2. Master the application of bit logic instructions. 3. Learn how to write programs using bit logic instructions. 4. Be familiar with the meanings and applications of input relay instructions and output relay instructions. Task description. Traditional motor control primarily relies on hardware components like relays and contactors, as shown in the diagram. This setup results in complex wiring, makes changes to the logical relationships difficult, and has lower hardware reliability. In contrast, PLCs use software programming, which offers high reliability. Changing the logical relationships only requires modifying the program. Therefore, using PLCs for motor control has become the mainstream method for motor control today. This task focuses on controlling a motor using normally open, NO, and normally closed, NC, contact instructions and coil instructions. It includes controlling the start, stop, and continuous operation of a single motor, as well as its forward and reverse operations. The control of a single motor for start, stop, and continuous operation primarily involves managing the motor's startup, stopping, and continuous running functions. The forward and reverse control of the motor focuses on managing the motor's forward and reverse rotation, including starting, stopping, and continuous running. Additionally, to prevent conflicts between forward and reverse operations, interlocking control is implemented in the programming to ensure that both operations do not occur simultaneously. Task analysis. To achieve the start, stop, and continuous operation control of the motor, the following tasks need to be performed. First, implement start and stop control of motor. The continuous operation of the motor means that when the start button is pressed, the motor should be powered on and run. When the stop button is pressed, the motor should be powered off and stop running. Use contactors in the main circuit to control the power supply. Second, implement holding control of continuous operation of motor through latching control. After detecting the start button press at the PLC's input, drive the relay coil and associated contacts at the PLC's output to ensure continuous operation of the motor. Finally, conduct online debugging. Load the program into the PLC, connect the PLC wiring, and implement motor control actions according to control requirements to verify the correctness of the program. 3. Knowledge map. The knowledge points for this task include learning and applying normally open, NO, contacts, normally closed, NC, contacts, coils, and inverted coils. The diagram above illustrates the ladder diagram representation of NO and NC contacts and coils. This course primarily uses ladder diagrams for programming, and these NO, NC contacts, and coil diagrams will be frequently utilized. Detailed explanations of NO and NC contacts, coils, and inverted coils instructions are as follows. NONC refers to the status of the contact when the operand is 0. The NONC contact instruction outputs are 0, 1, off, on, respectively, maintaining their original states. When the signal status of the operand, contact address, is 1, the NONC contact is activated and the output states are 1, 0, on, off. At this time, the NO contact closes and the NC contact opens. In contact instructions, the data type of the variables is bit bool. Contacts can be connected in series or parallel, but cannot be placed at the end of the ladder logic rung. 2 series contacts perform an AND operation, while 2 parallel contacts perform an OR operation. The coil (parentheses) and inverted coil / inside parentheses instructions are used to drive specified operand coils. If the logical result RLO of the coil input is 1, the normal coil (parentheses) will be activated and the inverted coil / inside parentheses will not be activated. If the RLO is 0, the drive coil (parentheses) will not be activated and the inverted coil / inside parentheses will be activated. In contact instructions, the data type of the variables is bit bool. Coils can be used in parallel, or multiple coils in series. The same coil should not appear more than once in the same program, as this will cause logical confusion. Figure 2 illustrates the application of the AND operation for drive coil. From the diagram, it can be seen that NO contact I0.0 is in conjunction with NC contact I0.1. When the logical result of the AND operation is 1, drive coil Q0.0 receives power and is in the state of 1. Conversely, when the logical result of the AND operation is 0, coil Q0.0 does not receive power and is in the state of 0. Figure 3 illustrates the application of the contact or operation drive coil and inverse coil. From the figure, it can be seen that NO contact I0.0 is in parallel with NO contact Q0.1, and this combination is then in series with NC contact I0.1. When the logical operation results in 1, coil Q0.1 receives power and is in the state of 1. Conversely, coil Q0.2, being an inverse coil, does not receive power and is in the state of 0. When the logical operation results in 0, the states of the coil and the inverse coil are opposite to those when the logical operation results in 1. Figure 4 presents an example of using the AND operation to drive multiple series-connected coils. From the figure, it can be seen that the same inputs can drive multiple coils, and the coils can be connected in series. When the result of the AND operation between I0.0 and I0.1 is 1, both coils Q0.0 and Q0.1 receive power. Figures 5 and 6 illustrate common programming errors. In Figure 5, NC contact I0.2 is placed after coil Q0.0, which is not allowed in S7-1200 PLC programming rules. In Figure 6, the Q0.0 coil appears twice, which is a typical dual coil programming error. In Network 2 of Diagram 6, NO contact I0.0 and NO contact Q0.0 are parallel. The state of Q0.0 is determined by the coil controlling it. With two Q0.0 coils, it becomes unclear which coil determines the state of Q0.0, leading to logical confusion. Therefore, the same program must not include duplicate coils. This concludes today's lesson. We will continue in the next lesson.